Okay, so for today's lesson, so this is section 1.7, day 3, you guys will continue to be working on absolute value inequalities. Now, the other day you learned about if you have an AND problem, right, you shade in between. If you have an OR problem, though, then that means you shade on opposite sides. But today, these are going to be a little bit trickier. So these inequalities don't quite work like they usually do. So let's go ahead, let's go and do example 1. So you do exactly what you've been doing before. You create two inequalities. So we write x plus 1. So we write the inequality that we see. It's greater than or equal to negative 16. Then we write our second inequality, which is going to be x plus 1. Remember, we flip the inequality, and now we negate. So since it was already negative 16, we now make it positive here. Okay. So if we look, though, at our original inequality, we can see that we have a greater. Okay. So remember, that's going to come very handy later on. Okay, so we have a greater. There we go. So greater than or equal to inequality. So it's an OR. Okay, let's go ahead. We're going to solve both of our inequalities. So here we know we have to subtract 1 from both sides. And we should get x is greater than or equal to negative 17. On the other one, once again, we subtract 1 from both sides. And here we should get x is actually less than or equal to 15. And so here we're going to have our OR. There we go. So now putting this on a number line. Okay, actually, let's do blue. Okay. So we have, let's say, negative 17 all the way over here. Let's just say we have 0 in between, and then we have 15. Okay. Now, remember, what I like to do here is instead of just drawing right on this number line, do it above so you can see what your answer is, and then place it on the number line. Okay? So this is saying x is going to be greater than or equal to negative 17. Now, notice there's an equal bar, so that means that you need to have that closed circle. So I'm going to just create a closed circle. Remember, greater than, that means numbers bigger than negative 17. So you just draw your arrow to show, oh, so basically that inequality is just saying we want numbers bigger than negative 17. Okay. Now, as for the x is less than or equal to 15, for that one, once again, since we have the equal bar, you create a closed circle. And now this is really saying that we want numbers smaller. Right? There we go. Now, yesterday, whenever we had OR problems, right, as I said before, we usually drew on opposite sides. But as you can see here, the lines cross. And so basically, this is saying that you can have any numbers that are bigger than negative 17, so this goes on forever, and any numbers that are less than 15. This is really indicating, because we only want x values, basically that satisfies at least one of these conditions, okay? If they satisfy both, that works as well. So because we have numbers that probably satisfy one or both of these, like if we had maybe negative 15, well, negative 15 is greater than or equal to negative 17, and it's less than 15. But you also have numbers like negative 18, who's over here, which is just basically less than or equal to 15. And numbers like 16 over here, in which they are greater than or equal to negative 17. So this is saying that because we have an OR problem and our lines are intersecting, we actually are going to have the entire number line as our answer. So putting this on our number line, all you have to do is we're going to shade this entire number line, because every number satisfies the two conditions that we have up here. So they satisfy x is greater than or equal to negative 17, and they satisfy x is less than or equal to 15. So now writing an interval notation, because we have all negative numbers, remember if it goes on forever and we have all negative numbers, we have negative infinity. And then because we have all positive values as well, and it goes on forever, we have positive infinity. Now remember, when you're writing this in interval notation, you use parentheses with your infinity signs. So now our interval notation is negative infinity to positive infinity. Okay, now we're going to do the next one. Okay. Now for the next one here, if we look at our inequality, this is a less than. And that really means this is going to be an and problem. So less than, right? Okay. First things first, create your two inequalities. So we start off with 2x minus 1, which is less than negative 25. Basically, you're just writing the inequality you see here. And now our next one, which is going to be 2x, once again, minus 1. We flip the sign, so now it becomes greater than, and then we now negate. So since it's already negative 25, when you have two negatives and you're multiplying them, they make a positive. Now we already said this was an and problem. Okay, there we go. So let's go ahead. We're going to solve both of our inequalities. So we add 1 to both sides. So we should get now 2x is greater than negative 24. And then divide both sides by 2. We should now get x is less than negative 12. Okay. On the other side, once again, we add 1 to both sides. So we have now 2x is greater than, well, we say 26. Divide both sides by 2, and we should get now x is greater than 13. Once again, if you need to remind yourself, and, right, this is an and problem. So let's go ahead. We are now going to graph our answers on a number line. So we draw our number line. Okay. So let's say we have negative 12 on this side, right? We have 0 in between, and then we have 13. Now remember, I always like to draw the lines above the number line to actually see what my answer is. And then once I know my answers, then I put it on the number line. So this right here is saying x is less than negative 12. What that means is we want numbers that are smaller. And so that's going to mean that we're going to have numbers that are on the left-hand side of negative 12 on this number line. Now notice we don't have an equal bar, so that means our basically circle is open. And we're going to show that our arrow goes to the left, because those are all the numbers smaller than negative 12. Okay. Now our next condition, which is x greater than 13, once again, we don't have an equal bar, so our circle is going to be open. This is indicating that we want numbers bigger than 13, so like 14, 15, 16, etc. And so it goes on forever. We're going to draw a line in our arrows. Now, usually when we saw this, right, it was an or problem, but this time it's an and problem. And now let's kind of talk about what happens with this. Remember what and means. It means that you have to satisfy both conditions. So any x value has to satisfy the x is less than negative 12, and it has to satisfy that it's greater than 13. Now you're thinking, well, how do I know it satisfies? Let's choose a number in between negative 12 and 13. Let's just say we pick 0, right? Well, if we plug 0 in for x here, right, is 0 less than negative 12? Oh, it's not, right? This does not work. It is false, okay? So what about 0 being greater than 13? Well, that is also false. So because we have 0, and we can think of any numbers in between, because they do not satisfy both of these conditions, right, In this case, we will have actually a no solution because we have to have x values that satisfy both conditions. If we do not, then there are no solutions. No x values work for this inequality. And so when that happens, we don't put anything on the number line, and our final answer is just no solution. So you don't even write anything in interval notation. Okay? Okay, so what I would like you to do next is try number 3 and 4. So this is a good time to pause it. If you want to pause it, then work on 3, and then see if you got it correct. You could do that. Or you could do both 3 and 4 at the same time. Pause the video and work at that at the same time, and then see at the end what you got. Okay, so go ahead and pause the video, and so you can work on number 3 and 4. Okay, so hopefully you paused it. So try this. If you didn't get it, if you were still confused, that is okay. This is why we have this video. So I'm going to go ahead and explain what's happening. So let's talk about 13 first, okay? So we're going to talk about 13. Whoops. Okay, so with 13 here, right, once again, we have to create two inequalities, no matter what, okay? So our first inequality is 2x plus 1, which is greater than or equal to x minus 4. Our next inequality is, once again, the 2x, oops, that should be plus 1, there we go, plus 1, which is flip the sign, so we want less than or equal to, and then we have to actually negate this whole thing, this x minus 4, okay? So what I did was I put a negative on the outside of the phrase, or of the expression. Now you can see I have this word or. Well, the reason being is, if we look at our original inequality, this is a greater than or equal to inequality. Okay, so it's a greater. Okay, now knowing that, let's go ahead, we're going to solve. So we are basically solving for x. So here all I did was I added 1 to both sides, right? And really, all I did was actually move the x on this side. Sorry, so I subtract x from both sides. So 2x minus x gives us x. I have still plus 1, which is greater than or equal to negative 4, okay? On the other side, right, all I did was I distribute the negative to both the x and the negative 4. So now we have negative x, and this makes it a plus 4. Okay. Now, going on here, now we basically have to solve it. So here, this is easy. All you do is subtract 1 from both sides. So now if x is greater than or equal to negative 5. Over here, though, I had to take extra steps. So here, I added x to both sides because this is a negative x, and I get 3x. Now, I did kind of 2 moves in one step. I added 1 to the other side to give me 5. To get x all by itself, I just divided both sides by 3. And so my second answer is x is less than or equal to 5/3. Now, going with that, we have to create our number line. Okay. So we have negative 5 on one side, 0 in the middle, and then 5/3 on the other side. Now, remember, try to do your inequalities on top of the number line first, and then decide, well, what is my answer, and I'll put it on the number line. So the first inequality is saying that x is greater than or equal to negative 5. Well, because we have that greater than symbol, we are going to make a closed circle. And this is basically saying we just want any x value that is bigger than negative 5. Well, if we're going bigger, we're actually going to go towards the right. So we're going to have an arrow that just goes towards the right. Now we look at our second condition, or inequality. It says x is now less than or equal to, well, remember that equal bar means we're going to have a closed circle, then 5/3. Basically, this is saying we want any x value that is smaller than 5/3. So smaller means we're going to go towards the left. Now, usually we solve this when we did and problems the other day, right? But now we have an or. Remember, your x values just only need to satisfy one of these conditions. if they satisfy at least one of these conditions, it is a solution or an answer. For example, if we picked 0, right? Well, 0 is greater than or equal to -5. It's bigger. And 0 is less than or equal to 5/3. That is the solution. So because that is the solution, we know we need to shade, well, in between. But what about numbers on the outside? Let's say for -6, right? Well, if we plug -6 in for x for our first condition, it is definitely not bigger or greater than -5. However, if we just plug it into the second condition or inequality, -6 is less than or equal to 5/3. So any numbers that are on the left-hand side of the -5 on our number line are solutions. And so now you think of, well, what are numbers bigger than 5/3? Let's pick the number 3. Well, if we plug 3 in for this x, right? Well, 3 is greater than -5. So any numbers to the right of our 5/3 are solutions to our inequality. Because we shaded the entire number line, and if we went forever, we would shade the entire number line, we incorporate all of the numbers on the number line as our solutions. That means we have all negative numbers, so we represent anything going on forever, and negative numbers as -infinity. And we have all positive numbers as our solutions. So we represent that as +infinity. And so our interval notation is now parentheses. Remember, we use that for infinity signs. -infinity to +infinity. And then the answer in your number line, you just basically shade everything that's on the number line, because all the numbers are your solutions. Okay, let's go ahead. Let's do number 4. So once again here, we have to, now this is a little bit different, because if you look here, and this might trick you a little bit, we have this 3 that's on the outside of our absolute value. Whenever you have any numbers outside of the absolute value signs, like this 3, or you might have like a +6, something like that on this side, you have to actually get rid of it first, and then you create your 2 equations. So we're actually going to divide both sides by 3 first, and rewrite our absolute value inequality. So we know these 3's cancel out here, so we're left with absolute value of x minus 7. We keep the absolute value signs. Okay, those don't go away yet because we have not written our 2 inequalities. Then we say is less than or equal to, and now we do -12 divided by 3, which gives us -4. So now this becomes our original inequality. And if we look here at our sign, right, part of it, this is our less than. So this becomes a and problem. So less than. There we go. So now, using our new original equation, we write 2 inequalities. Okay. So the first inequality, we have the x minus 7, which is less than or equal to -4. On our second inequality, we keep the x minus 7. Remember, we flip the inequality, and we negate what's on the opposite side. Remember, 2 negatives make a positive. And really, our inequality is an and problem. So now we solve both inequalities. So all you have to do is add 7 to both sides for here. So 7 minus 4 gives us 3. So we get x is less than or equal to 3. On the other one, same thing, we add 7. So now we have x is greater than or equal to 11. Now what we're going to do is write or create our number line. So we have our number line. So we have 3. Now, 3 and 11 are both positives, so we can't put 0 in between. So what I'm going to do is just put a random number that's between these two, and let's just say it's 8. Okay? And then we have 11. So you can pick any number that's between 3 and 11 as your middle number. Does not matter. Okay, now if you notice, once again, we have equal bars, so our points are going to be closed. So first condition, we have x is less than or equal to 3. So we create a closed circle. And basically what that means is that we want numbers smaller than 3. Okay, so all x values that are smaller than 3. Well, any x values that are smaller, we always go to the left. Okay. Now for a second condition, says x is greater than or equal to 11. Once again, closed circle. And what we want are all x values that are bigger than 11. So whenever we want to get bigger, we go to the right. Now here, usually we saw two opposite sides shaded when it's an OR problem. So what happens when we have an AND problem? Well, let's see with this number in between 8. Now remember what AND means. It means that our x value has to satisfy both conditions. So our x value has to be smaller than 3, but it also has to be bigger than 11. Let's see if this is possible. So let's pick our number 8, right? So if we plug 8 in for x, is 8 really smaller than 3? Is 8 less than or equal to 3? No, that is not a true statement. Well, then let's try the other one. Is 8 bigger than 11? Or is 8 greater than or equal to 11? No, that is also not true. Well, because it satisfies, none of the conditions, as well it doesn't even satisfy one of the conditions, we can't shade anything in between. Okay? And usually with our AND problems, we do shades between two values. Because we're not able to shade between these two values like we did the other day, really, we have no solutions. Because we don't have anything that satisfies where the number is less than 3, but bigger than 11. So because we don't have any values that satisfy both of these conditions, our final answer is going to be a no solution. And so when this happens, you are not able to draw anything on the number line. If you did, that would be incorrect. That's why we want to draw our arrows above first to see what our answer would be. So our final answer would be no solution. So basically, I'll do another video that will talk about tolerance. Now, if you have any questions, remember, email me, and I will have these notes, these filled-in notes, up on Google Classroom as well. And then you can always come in before or after school to get some extra help on these problems.